So there have been some gap in studying. So today we are resuming our blockchain studies. We have put around 10 hours. We probably require around 300 hours. So let's start with it. Let me check the audio once. Around 300 hours. So let's start with it. Let me check the audio once. Around 300 hours. Audio is working fine. I'm sure the desktop audio is also fine. Let me check once. Audio is working fine. I'm sure the desktop audio is also fine. Let me check once.
Hi everyone, quick announcement before we start the video. I know it's been a while since I've actually made a coding video. Just wanted to share that I'm creating a very long one on Web3 around 4 to 5 hours, and that'll come hopefully very soon, but that's why things have been slow. And just to maintain the frequency of the channel, I'm putting out such alpha videos which hopefully help a few of you guys. But yes, real coding videos will be out very soon. So today's video, I wanted to talk about winner mindset, how people who are in the top 1% have differentiated themselves from the bottom 99%, specifically when it comes to software development. Why I feel that if you take everyone today and put them at the same slate, in the next 5 years, the people who were successful today as software developers will again be successful in the next 5 years. The reason is that I feel that this is a very learnable skill, and the people who have differentiated themselves today know something which I'm going to teach in this video, and hopefully some of these habits you can inculcate that will help you in the longer run. Let's get right into the video. I want to talk about this thing called the winner mindset. So the CEO of Coinbase once said that you can take away my company and you could basically clean down to zero. As long as I have my laptop and a good internet connection, I will be able to build all of this up again. I think this is a very common mindset in all good technologists I know, where they don't really care about macroeconomic effects or what's sort of taking down the world of software development. They're really just focused on their work, and money is a very nice byproduct of what they're doing on a day-to-day basis. They don't really look at their bank account or their overall comp. And usually when they're switching from one company to another, it's because of better work or like more challenging work that they're looking for in the new company, more than compensation. Although I've seen that compensation or good compensation always follows these people. So what is advice number one? Advice number one is don't be faced by cycles. Cycles come and go. In the end, if you're in technology, you will find a way to be employable. But more importantly, where you should be spending your time is learning and growing as much as you can. With that, let's move to the second point. Choose very wisely who you're spending your time with, and very strongly think about who your inner circle is. What is the inner circle? It's the top 5 people that you're talking to on a daily basis. People say that you're the average of 5 people around you. I think that's very true. Especially in tech, I've seen strong devs cluster together. Look at good big startups. Look at remote software developers. Look at sort of people going to Google as well. You'll see or find a pattern that there was a group somewhere of 5 to 10 people, and they were very passionate towards one thing, which doesn't necessarily have to be, especially when you're starting your career, doesn't have to be tech. It could be a job, but they all had a common goal and were inching towards it. When you have this inner crew that's all sort of behind a certain goal, in tech specifically, I've seen the best startups in India, the most successful ones.
Something's wrong with my internet these days.
All started with a very small, strong team of people who knew each other very well. All my friends who went for a PhD were writing research papers together when they were in college. People who went into entrepreneurship were people who write a bunch of ideas on campus. And I think this applies very well to software developers. I personally have created a Discord, even though I'm extremely inactive there these days because of my course. But you should join it. At some point, I'm going to create an inner circle. I'm going to create a community when I have the time where I can sort of just put out alpha. And a lot of times, these passive things that you hear in this group lead to very solid impact. Like one small thing that you hear here might lead to a very big impact 3 years down the line. You just don't see it yet, which takes me to my third point, which is the butterfly effect. I think it's very common in tech for the people who don't know. Butterfly effect is a phenomenon/theory which says a butterfly flapping its wing in one corner of the earth could lead to a tornado in another part of the world. It could be as powerful, or just a lot of circumstances could lead the very minute amount of wind that generates from a butterfly flapping its wing to convert into a tornado. Personally, for me, I've seen this only once in my life when I was very mindlessly scrolling in my phone one night, and I came across this freelancing platform. This is when I was not a freelancer, I was a full-time employee looking for my next thing back in March 2020. I just came across this website, and on my phone itself applied for it, which means I was on Reddit, and Reddit opens the worst sort of browser. It does not open Chrome natively. It opened in the worst browser. I did not feel like logging in with my email and password and verifying my email. But this was like a very small 2-minute effort that I took, which we all know when you're scrolling at night on your phone on the internet, a very hard thing to do when you have Instagram and other things, other places you want to look at. Thanks to our small attention spans. Yet I took the conscious effort and applied for a platform which looked like a very American platform, and there was a very low probability, at least from my first looks of it, for me to get in. I got my first interview. Very passively from my bed, I gave the interview because I was still on bed from my medical leave, and it was my second interview after which I became slightly serious. So this was something I never really expected to happen, but this platform became my primary source of income for the next 2 years. It is what gave me the confidence to become a full-time remote software developer, and it started from a very random scroll on Reddit, which takes me to the point. If you can, if you're young and you're looking for your first job, if you're in your first job looking for a remote opportunity, whatever, if you're trying to go to the next pedestal, in Hindi there's a saying, which in English means keep sort of mindlessly throwing your hands left, right, and center till you find that first opportunity. You take small steps today, which could be like going to a conference. If it's far away, even if you have to go in a train there, and if you have to sort of take care of accommodation yourself, do it, because it could lead to one recruiter that you meet there, which could sort of change your life. Because you all know there are like stages in tech, and your first stage, which could be your first job, could just come from one such very small butterfly effect moment. So try to chase this, be it through finding time, speak through meeting people online. Don't be shy / restricted when it comes to looking for opportunities. One small butterfly effect moment could change the trajectory of your career. With that, let's move to the next point. Take risky bets. The good thing about tech is even bets that are considered traditionally very risky are not really risky in tech. If you're starting a startup, you can easily raise a few $1,000, maybe more than 100K, and you can take out a humble salary from it. Compared to non-tech traditional startups, the upside isn't as high, and you're still taking similar risks, and you might not be able to raise venture money. So thankfully, a lot of rich people who want to build / hold on to / grow their wealth believe a lot in technology, at least today. And for the same reason, they invest a lot of money here because they feel they get asymmetric upsides by investing in these young people. They are still fairly safe bets, and I don't know why, but every time I've seen someone take a risky bet in tech, at least in my circle, they've done very well. Now, you could argue that my circle is IIT folks, which is why this happened. I don't think it's necessarily true. I've seen people from tier 2, tier 3 colleges, my friends who've started their startups and are doing pretty well. And this would feel conventionally as a very risky sort of a bet, but almost always in tech I've seen it work out. So just move out of that circle of the salary trap, and if you can, take risky bets. Take bets where you feel you can grow technologically much more, even if it means a salary cut or less job stability, because the learning that you have will compound. That's what ends up mattering in the end after 5 years. Making 1.5x or 2x more right now won't matter much. Where you are technically in the next 5 years will matter much more. And hence I strongly suggest that bet that might feel risky, that new startup that might be technologically great but isn't paying you as much, try to take that bet. I think, and I could totally be wrong here, but every time I've seen people move from big tech to startups, it's very hard to move back. Similarly, on-site jobs, remote work, you don't really think of that as an option anymore. Even the worst case of remote job feels much better than sort of an on-site job. Similar to even the worst case of a startup, it could be the startup for going to shit, feels better than a monotonous 9 to 5 sometimes in a big tech. So it just feels, it's just very hard to take that first step. But once you do, I'm seeing this happen much more in India thanks to Shark Tank. So people are taking risky bets, and hopefully that tradition continues, because it is through these risky bets and us trying to challenge the conventional mindset going to 9 to 5 that humanity grows. So too philosophical of a video now. So let's get back on track. If realistically, if you have an offer to move to a startup with less upside, take it. If you're thinking going for a master's is too expensive, you could have exponential upsides after 2 years. Sure, 2 years will be difficult, and there is a risk. What if market goes to shit? In 2 years, you still have student debt to pay. But again, as I said, markets came and went. I saw the whole COVID cycle where a lot of my masters or friends, people who went for their masters, did not have any jobs, but it only continued for 6 months. And after 6 months, they're all working in Meta, Google, wherever. So it just feels like it'll be risky. It isn't in the end. For some reason, in tech, risky bets work out. I don't know why. We're just privileged, I guess, that a lot of money flows into tech, and so even the worst case here is much better than sometimes the best case in other places. So please, this is something that you will have to do, not me, but I've seen it work out. When you're ever getting that option right, just move. You can always come back to the less risky bet, maybe get paid a little bit less, but at least you try. One last point, forget books, forget notes. I think we've sort of been traditionally very wired to learn from books, be it in school, and especially in India, we go through IIT prep before going to campuses. It might feel like that's the right way to learn. Unfortunately, in tech it isn't. In IIT it is, even in school it might be, but in tech, the only way to learn, other than if you're a complete prodigy, is by doing. So build a lot of projects, and usually your motivation to build a project is good when someone is paying you. So try to find people and let them pay you, even if it's really less money. If it's like $300 for a React website, tell them I'll do it. At least you have a deadline. At least you have some upside at the end of it. And slowly and steadily, that's how you learn. The best way to learn initially is to keep underpricing yourself, even if it's not $1, but like even if it's like $200. I'm sure you can find people who pay you $200 for a website. A full stack website, it'll take you 100 hours. It'll be like $1 an hour or something like that. So extremely low pay, but you're not doing it for the pay. You're doing it for the learning. Trust me, you spending $100 on a book and reading it versus you getting paid for $200 and building a project, second one is much better. I have never learned from a book. Most best people I know don't learn from books. So try to leave the whole notes and learning from books behind and start building projects, be it full stack, be it whatever. Open source companies are out there. Leave companies, code bases are out there. You can learn and literally read how OpenAI is working these days. Not OpenAI, a bunch of open source alternatives of these. So just be curious and as much as you can, try to read through code bases of projects. If you don't understand them, then take a step back and build a smaller project. But tech is a very hodgepodge field. It's extremely haphazard, and I think the best way to learn is not have a structure. Just have projects that hopefully are milestone based and you're getting paid for them. Because if you pick up a project on your own, most probably, I will give it at some point, someone is paying you, you'll probably have some accountability. So if you can get someone to pay you for a project, if you want to get into ML, should be an ML project. If you want to get into full stack, build a website slowly and steadily. Through projects is how you learn everything end to end. Like learn how to build, then learn how to deploy everything that's needed in a production scenario. If you create for clients initially through freelancing, slowly you'll become really good at it. And by slowly, I mean literally in 6 months. So try to spend your time there and make that your learning framework versus reading books or even scrolling through YouTube videos. I think that's the best way for you to learn. So the last point is be appropriately irritating. I think a lot of you are struggling with, I'm not getting my first job, or there are so many people in the market, how do I differentiate myself? I think the answer is, I've also learned this through a lot of trial and error. The answer is being appropriately irritating when you're approaching people. So you have to realize people are very busy. People, today's market, no one is going to reach out to you unless you're really good. You are the one who has to reach out to employers, companies, HRs. And there is a very right balance of being irritating when you're approaching them, which means approaching them every few days, but not sort of pissing them off. Employers are usually very busy. They don't really care if you're messaging them, and they won't get irritated the first time. If you keep messaging them or you send them the wrong things, then they will. But if you're just being polite, showcasing your work, which in open source is just contributing to them very slowly and you're nudging your way in. And if it's not open source, if you want to get into a company, just getting in touch every few weeks. They know you, they know there's this person. Whenever they have this opportunity, if you're there at the right time, I've seen this many times that someone reaches out to me, I don't have the job right now, but I know at the back of my head there's this full stack person. If they keep sending me their projects every few weeks, every few days, I will be aware that this person exists. Whenever people are employing, right, there's just one crisis day that, oh fuck, we need a full stack developer today. So you just need to be if you're lucky, you'll be messaging them the same day. This has happened with me many times that someone who's been sort of pissing me off for a few days luckily messaged me the same day that I was looking for someone to hire. So find the right balance of being appropriately irritating, especially when you're trying to approach companies remotely. If you're at the right place at the right time, sort of a fit in, and that's a very ad hoc way to get hired. So be appropriately irritating, but if you're good at coding, just sort of keep contributing to open source and don't even leave things to chance. But if you can't yet contribute, and if you're contributing, they're not noticing you yet, keep nudging them that you're looking for a job. At some point, there will be a crisis in the company. They'll need someone will resign, or they'll get some funding from somewhere. They'll need more developers, or they'll just realize that this project is going very slow. We need a new developer. You should just be positioned very well, which in case of open source is just keep contributing. There will come a day, and then you should just be there at the right place at the right time. That's the best way to get hired. Cool. All right. This was a long video, but this is all my sort of factors that I've thought and seen that differentiate the top 1% or people who find opportunities even in this market and good opportunities from the rest of the group. Let me know if you like the video. If not, dislike. I'll see you in the next one. Bye, guys.
how IPFS works. I need to stable a little on the laptop. Can I increase the height a little? This is the highest it can go. IPFS works. It is a conceptual guide. You will learn about major in this subsystem that IPFS is composed of and how they work. There are three responsibilities of IPFS subsystems: representing and addressing data, routing data, and transferring data. Let's start with what is IPFS. IPFS is a modular suite of protocols for organizing and transferring data. Designed from the ground up with principles of content addressing and peer-to-peer networking. This light is a little harsh. Modular suite for protocols for organizing and transferring data. Designed from ground up with principles of content addressing and peer-to-peer networking. Peer-to-peer networking I understand. What is content addressing? Way to address data by hash rather than its location. What do you mean by address? Because of IPFS, it is open source and there are multiple implementations of IPFS. While IPFS has more than one use case, its main use case is publishing data, files, directories, websites, etc. in a decentralized fashion. Defining IPFS. The term IPFS can be referred to multiple concepts. An implementation of IPFS protocol, specifications such as Kubo. A decentralized network composed of IPFS node. The terms IPFS can refer to multiple concepts. What is the full form of IPFS? Did I encounter it yet? Interplanetary file system. Wow. IPFS isn't. The module is a protocol standard for organizing and transferring content address data. What IPFS isn't? IPFS shares similarities with and is often used with in architecture with the system described below. IPFS is not storage provider. While there are storage providers built with IPFS support, typically known as pinning services, IPFS itself is a protocol, not a provider. IPFS is a protocol. What are protocols? I'm going to know a little bit on internet protocols. IPFS. And I want a cool video, not something that looks like this. I'll have to see this one. आइए जानते हैं इंटरनेट प्रोटोकॉल्स क्या होता है.
Hello, welcome to another video from Module 1 of our Networking Fundamentals series. This module will teach you everything you need to understand how data flows through a network. This is Lesson 6, where we will unpack the idea of networking protocols and give you a brief description of a few important protocols you should know about. Now, we've actually used the term protocols a few times in this course without giving you a formal definition, and I'd like to start there. A protocol is simply a set of rules and messages that form an internet standard. For example, we've discussed the Address Resolution Protocol, or ARP, in this course. We've told you that ARP resolves IP to MAC mappings. This allows two hosts to discover each other's MAC address if all they know is their IP address. They do this by sending out an ARP request, and the receiving host sends an ARP response. The key, though, is someone had to determine what an ARP request looked like, what question was asked in the ARP request, or what information was included in the ARP request, or what to add as the destination MAC address in the ARP request. In the same way, something had to decide what an ARP response looked like. Well, in the case of ARP, that set of rules is defined by RFC 826. You can actually look up RFC 826 to see the specific rules for what actually makes an ARP conversation. The RFC are the engineering implementation guidelines for how to do ARP. This RFC has all of the rules that govern what an ARP request is and what an ARP response is. And the fact that these rules are published as an internet standard allows ARP to be implemented by many different vendors. That's what will allow a HP server to speak to a Apple MacBook, or a Dell laptop to speak to a Samsung phone. All of these different vendors are simply following the public open internet standard for ARP, and that's what allows them all to speak the same language when they are doing ARP with one another. That is the definition of a protocol. Again, it's simply a set of rules and messages which create an internet standard. Just like ARP is an important internet protocol that you should know about, there's a few other internet protocols that I'd like to introduce to you, starting with File Transfer Protocol, or FTP. FTP allows a client and a server to send and receive files from each other. The FTP conversation is made up of messages that look like this. The client would send the RETR command, which stands for retrieve, and ask for a particular file, and this would prompt the server to respond with that file. There's also the SMTP protocol, which stands for Simple Mail Transfer Protocol. This is the protocol that email servers will use to exchange emails. That conversation looks like this. The client will send the hello command to an SMTP server. The SMTP server will then respond with a response code of 250, and now the client and the server can exchange emails with one another. Hello and 250 are simply some of the messages in the SMTP standard. There's also HTTP, which stands for Hypertext Transfer Protocol. This is the protocol you're using anytime you're communicating with a web server. Web servers host many web sites written in HTML, which stands for Hypertext Markup Language, and those HTML pages are exchanged using HTTP. When you browse to site.com, your client, your web browser, is sending a GET request to the web server, and the web server will respond with a 200 OK message and then provide the website you're asking for. There's also the SSL and TLS protocols, which allow a client and a server to build a secure tunnel between themselves, and then they can do that HTTP conversation within that tunnel. That process is what's known as HTTPS. That is in fact what HTTPS stands for. It's an HTTP conversation secured within an SSL or TLS tunnel. That's what allows you to browse the web securely. So that's a quick rundown of some of the important protocols that exist on the internet. There are thousands of protocols out there, and all of them contribute to some sort of functionality in the internet ecosystem. And there's two more rather important ones that I want to talk about, but first I want to focus on the host for a minute. In lesson 1, we told you that a host is anything that sends or receives traffic, and that hosts are typically divided as clients or servers. But we also said that a server is really nothing more than a computer that knows how to respond to specific requests. Meaning, each of these servers are really just computers that have FTP software installed, or SMTP software installed, or HTTP or SSL software installed. Which means, these clients and servers all follow the same rules of host-to-host communication that we unpacked in lesson 3. And one of the key elements of that is for a host to speak to another host, it must know the other host's IP address. Now this will work for this client to speak to the FTP server, because we can see the IP address right here. But how does it work for this client to speak to the SMTP server or the web server? If I asked you for your favorite websites, you would probably give me the domain names of your favorite websites. Or if I asked you for your email address, you would give me something that looks like this. You wouldn't give me an IP address. Lucky for us, there is a protocol that exists which will translate these domain names into an IP address. And that protocol is DNS, or the Domain Name System. DNS will use a DNS server to convert a domain name into an IP address. The way it works is when you type in a website into your browser is first going to make a request to a DNS server asking for the IP address of the website that you just typed into your browser, and then the DNS server will provide an IP address, and this will now allow your host to make a request to the actual web server IP address, even though you never provided the website IP address itself. Your computer was able to figure it out automatically by using the DNS protocol. DNS is also what makes email possible. Again, if I were to ask you for your email address, you'd probably give me something that looked like this, and not the actual IP address of your email server. But DNS would resolve this into your actual mail server's IP address, and now your client can actually send mail to the mail server. So as you can see, DNS is actually a pretty important protocol in the internet ecosystem. And in fact, DNS does so much more than what we just described. But discussing the full depth of DNS goes beyond the scope of this particular module. We will cover DNS in more detail later on in this course. Now let's go back to focusing on this host for a minute. Anytime a host connects to a network, there are 4 items that need to be configured on this host to achieve internet connectivity. And I'm going to show you those 4 items in this box. The first of those items is an IP address. This is going to serve as the host's identity on the internet. And this host right here has the IP address 9.1.1.11. The next thing a host needs is a subnet mask. This is going to tell the host the size of its network. This will allow the host to determine if it's trying to speak to something on its own network or to speak to something on a foreign network. Now a subnet mask can look like this, /24, or can look like this, 255.255.255.0. Both of those are simply different ways to display an identical subnet mask. Either way, if all a host has is these 2 things, an IP address and a subnet mask, this will absolutely allow this host to speak to any other hosts on the same local network. But if this host needs to speak to something on a foreign network, for instance the internet, that host is going to need a router. And specifically, that host is going to need the router's IP address configured as that host's default gateway. With these three elements configured on this host can now speak through the router to the internet to any server using its IP address. But most of the time, when you're on the internet, you're looking at websites or trying to send email. And as we described a moment ago, you can't speak to domains without converting those into an IP address first, which means the fourth item that every single host needs in order to achieve internet connectivity is the IP address of a DNS server, so that it can translate domain names to IP address, so it can then communicate with other hosts using their domain names. These four things must be configured on every single host anytime it connects to a network. As we alluded to a moment ago, the definition of a host is anything that sends or receives traffic on the internet, which means a host could very well be your laptop, or your printer, or your mobile phone. In all cases, every time any of these devices connects to a new network, these devices must be configured with these four items. But some of you might be thinking, wait a minute, every time I connect to a new Wi-Fi network at the local coffee shop or the hotel or an airport or my school network, I don't have to go into the settings of my phone and configure these things manually. Yet I can still reach the internet. Well, what's occurring behind the scenes is yet another important internet protocol. That internet protocol is known as DHCP, the Dynamic Host Configuration Protocol. What DHCP does is it allows a DHCP server to provide an IP address, a mask, a default gateway, and a DNS server for any client. This is actually what happens every time you connect to a new Wi-Fi network. Your host will send a DHCP discover message to discover the DHCP server, and then the DHCP server will provide these four things in response back to the client. Then your client has everything it needs in order to speak to the internet. And that is how every time you connect to a new Wi-Fi network, your phone or laptop automatically acquires the information it needs in order to speak to the internet. And that wraps up the main ideas I wanted to communicate to you in this lesson. The main takeaways of this lesson is understanding DNS and DHCP and their roles in internet communication, understanding the four things that every single host needs in order to attain any sort of internet connectivity, and understanding a high-level definition of each of the other protocols that we discussed in this lesson. For each of these, we really only scratched the surface for what those protocols do. We could spend hours talking about each of these and how they work. But for now, I just wanted to give you a quick idea of where each of these protocols fit into the overall internet ecosystem. Either way, that wraps up this lesson. I hope you enjoyed this video. I want to thank you for watching, and I'll see you in the next one. Hey YouTube, I hope you enjoyed that free lesson. I'm releasing this content for free to see how much interest there would be in a full Networking Fundamentals course taught in the same practical networking style. If you want the full course to be created, you have to help me out by spreading the word about this free module. If this content gets enough attention, I will definitely create the full course based upon your suggestions for what you want in a Networking Fundamentals course. Besides, I'm sure you know someone that would also benefit from learning how data flows through the internet.
I need to also learn about networking if I'm going to work with blockchain. Let me I get a certificate on networking? Service providers. Further reading. IPFS use cryptographic hashes to verify the authenticity and integrity of file, making it difficult for malicious actors to tamper with deleted files. Resilience. IPFS has no single point of failure, and users do not need to trust each other. In other words, the failure of single or in multiple nodes in the network does not affect the functioning of the entire network, and IPFS nodes can fetch data from networking as long as at least one or other nodes in the network has the data, regardless of its location. Centralization. IPFS is an open, distributed, and participatory network that reduces data silos from centralized servers, making IPFS more resilient than traditional systems. No single entity or a person controls, manages, or owns IPFS. Rather than it is a community maintained project with multiple implementation protocol, multiple tools and apps leveraging that protocol, and multiple users and organizations contributing to its design and development. Performance. IPFS provides faster access to data by enabling it to replicate it to retrieve multiple locations and allowing users to access data from nearest location. I'll stop the stream now. I have a meeting. I'll start a new stream after this.